How's everybody doing today? This is L.A.Kendrick with another tale from the vault of Would You Dare. Today we're going to discuss something really quick. I'm going to make it a short video. And we're discussing black holes. All right? And this might come as a little bit of a surprise to you because it kind of caught me off guard too. And I just want you guys to hear this article that was written back in November 3rd, 2019 by Haley Zaremba. All right. So let's and again, every time I talk about stuff like this, I've noticed that my YouTube views go down tremendously. I mean, it's like I have no views. They'll be really high, and then YouTube will just break them down. I don't understand what that means. Again, you guys hit that like button and that share button, get the likes up, so we can continue talking about topics like this. And again, I'm just doing it for fun. I'm not even serious about it. I'm just doing it for fun. And these articles are very, very interesting. All right. So, with that being said, let me go ahead and hit this story. All right. 2012 was a big year for black holes, or rather for our understanding of them. First Scientific American published a moderately terrifying paper titled Black Holes Are Everywhere, and then a team of researchers at Princeton University numerically solved the Einstein hydrodynamic equations in order to determine that black holes are in fact way easier to create than previously thought. The findings showed that the formation of a black hole requires considerably less energy than previous calculations suggested. Meanwhile, perhaps at least partly because of these revelations, concern of a world-destroying possibility, no matter how unlikely of a man-made particle collider opening up an Earth-swallowing black hole, has remained omnipresent in the larger conversation around atomic research. The ultra-realistic black hole formation study from Princeton University, published in 2013, developed new computer models which they utilized to show that the formation of a black hole would actually require less than half the energy, 2.4 times less to be precise, than previous research had determined. The study shows that the researchers found that the threshold for black hole formation is lower by a factor of a few than simple Hooke conjecture estimates. And moreover, near this threshold, two distinct apparent horizons first form, post-collision, and then merge. They've got a diagram down here, and they're trying to credit W.E. East and some other guy, F. Pretorius, Physics, whoever that guy is. As a report at physics.org explains, researchers know that it's theoretically possible to create black holes because of Einstein's theory of relativity, particularly the describing the relationship between energy and mass. Increasing the speed of a particle causes its mass to increase as well. This is what drove the Princeton researchers to form a computer model based on Einstein's original hydrodynamic equations. The model provides a virtual window for viewing what happens when two particles collide. They focus their energies on each other and together create a combined mass that pushes gravity to its limit and as well spawns a very tiny black hole. That result was expected. What was surprising was that the team found their model shows such a collision, the result will require 2.4 times less energy than has been previously calculated to produce such a tiny black hole. And our galaxy is positively chock full of them. It's not just the famous supermassive black hole at the center of the Milky Way. There's scores of smaller black holes as well. Scientific America's Black Holes Are Everywhere tells readers that most of the holes in our galaxy are perhaps 4 or 5 solar masses, and they're tiny, with horizons of only about 12 kilometers in radius, but there have been tens of thousands of them, the inevitable remnants of short-lived lives of huge stars. All right, this news feed into fears that mad scientists performing universe-breaking experiments were flying a bit too close to the sun, so to speak, by conducting experiments at the European Organization for Nuclear Research, CERN, Large Hadron Collider, LHC, with the potential to open up microscopic black holes with potentially disastrous consequences. These concerns surfaced before the LHC, an underground accelerator which forms a ring with a diameter of 5 miles near Geneva, Switzerland, which was switched on. An April 2000 report from NASA titled "The Day the Work Didn't End" tells researchers that bringing the accelerator online did not trigger the creation of a microscopic black hole, and that the black hole did not start rapidly sucking in surrounding matter faster and faster until it devoured the Earth, as sensationalist news reports had suggested it might. The fear around these larger-than-life experiments was so potent and widespread that CERN has an entire page on their website dedicated to frequently asked questions: will CERN generate a black hole? And even the Princeton scientists addressed it in their academic report, noting that even with the new calculations finding that black holes require much less energy to open up than previously thought, opening up a black hole big enough to collapse the Earth would still require billions of times more energy than the LHC is capable of generating. What's more, even if we had a black hole, even if and when the black hole did open up in the collider, it would disappear just as quickly thanks to an effect called Hawking radiation, which is Stephen Hawking, I believe. While the fears of Armageddon causing potential of these microscopic black holes may have been overblown, however, the fact that the particle can open up these tiny black holes was then and remains now an absolute truth. Even CERN's fact page concedes that the LHC will not generate black holes in a cosmological sense. However, some theories suggest that the tiny formation of quantum black holes may be possible. Of course, the page goes on to reassure concerned readers that the observation of such an event would be thrilling in terms of our understanding of the universe and would be perfectly safe. Yeah, when have we heard that before? Nevertheless, there are still some scientists who think we are right to be worried about these experiments that are probing the boundaries of physics. Just last year, the well-respected, not to mention knighted British scientist Sir Martin Rees published a warning to take fears around the LHC seriously in his book on the future. As paraphrased by NBC scientist news site Mach, M-A-C-H, particles crashing about inside an accelerator could unleash bits of strange matter that shrink the Earth into a ball 300 feet across. In another scenario, experiments could create a microscopic black hole that would gnaw away at our planet from the inside. In the most extreme scenario, Rees describes a physics mishap could cause space itself to decay into a new form that wipes out everything from here to the farthest star. Rees himself recognizes that these scenarios are extremely unlikely, but in the author's own word, given the stakes, they should not be ignored. And now that the Event Horizon Telescope has successfully captured the first ever image of a black hole, scientists are dreaming up ever more radical future experiments. Let's just hope that as scientists continue to push against the limitations of human knowledge and ability, the headline continues to read, the day the world didn't end, or that we continue to have headlines at all. And that's the end of that article. And this is just one of the things that was in Geneva, Switzerland, when they did the particle accelerator to open up a black hole. Now, you know, like, this is our planet, right? Why would they not want to do something off-world? Let's just say they want to do something in the International Space Station, right? Run an experiment there. Why would you want to do it on our planet? I mean, man is always playing around with trying to play God, and I don't get it. It's complicated and confusing, in my opinion. I don't know what to rightfully say about something like this, because to me this is science, but it's when it's that scary part because it's actually being done. So what do you guys think about stuff like this? Would you dare experiment with something like this and try to play God? Because I think this is extremely dangerous. What are the residual effects of something like this? You ever notice how these scientists always say something is safe or something isn't this and something isn't that, and then only to find out later on how devastating it is to the planet? Just check out the ozone, for example. That's just one example of the many things that we've said, oh, it's not a big issue, it's worth the risk and worth the experiment. Yes, some things are for the betterment of humanity. Yeah, but something like this is dangerous, man. A black hole, that is a star collapsing upon itself, and the weight of it punches a hole in the space and time fabric, right? Making a gravitational pull and force so great that light can't even escape it. That's not nerd. That's not me being a nerd. That's just fact and science. I can't understand why we always trying to play God down here on the planet. What is Prince saying? Sign of the times. Some say man ain't happy unless man truly dies. I mean, these people, they seem like they want to try to take everybody with them on their crusade to be great. I mean, you guys tell me what you think, man. Like, share, comment, and subscribe. Again, every time I make a video and it's talking about stuff like this with the government or anything like this, YouTube always reduces my number count, and I don't understand what that means. I'm just a small channel, and I'm basically doing this for fun. But this article kind of clicked the nerve with me and made me think, damn, this is kind of crazy. Yeah, I said damn, because that's serious. The residual effects we don't know anything about. Physics and science is a strange thing, man. And I think this is something that you shouldn't be messing with. Like, I don't know. So again, you guys, tell me what you think. I don't even know how I should end this one. I guess I'll end it like I always do. Remember, check your homes, check your closets, check all the dark recesses of your home, right? If you work at night or work late into the morning when there's very limited light outside, check inside of your cars and check under your cars. Because evil and monsters come in all forms. And you never know what's lurking in the dark to make you a story. And this has been L.A.Kendrick with a very, very, in my opinion, disturbing chapter from the Vault of Would You Dare, episode number 25. Like, share, comment, and subscribe. Please hit that like button. And you guys fill in the rest. Because this is our world.